Hey guys, this is section 1.2, exponents and radicals. We're really going to focus on three things. First, we're just going to look at what exponents are. Then we're going to focus on zero and negative exponents. And then finally, we're going to focus on some exponent laws. Just a quick note with watching these videos through Canvas and answering the questions, you do have to keep the video going all the way to the end. I did have a handful of students that answered the questions, and you guys did a great job with that. But then because you stopped it right before the end of the video, the website did say that you had not quite turned it in, and so that's why I wasn't able to grade it and wasn't able to see your score. So just a quick reminder, please make sure you watch all the way through the video. So with that being said, let's go ahead and get started. We're going to first start off with some vocab questions. Vocab words here. The first one is power, and a power is a number consisting of a real number called the base and then a positive integer called the exponent. So if you want to draw this out, the base is our big number, and then the exponent is the smaller number that's raised up a little bit. Coefficients are just numbers in front of a variable, which we'll talk about that. And then to simplify means to change an expression in which each real number appears only once and all exponents are positive. Parts of a root, the radical here, we're actually going to talk about that in the second part of the video, so I'll come back to that later on. Exponential notation in general, just exponents. Remember that exponents are used as repeated multiplication. So 5 to the fourth here, we have 5 as the base, 4 is our exponent, which means we're going to take 5 times itself 4 times over. Now this works for whole numbers like this. It also works for fractions, it works for decimals, and it also works for both positives and negative numbers. Now with negatives especially, we got to be really careful. So this one says we're going to take negative 3 times itself 3 times. That means we're going to keep the parentheses together and keep the negative 3 there, and we're going to take it times itself 3 times. Now this one, if you'll notice, or if you remember, that order of operations tell us to do exponents first. So that means that we need to focus on taking 3 to the third power first. And then once you simplify that, then that whole thing gets to negative. Now in this case, the answers are the same, but depending on what your exponent is, the answers could be different. Next, we're going to focus on two types of special exponents. First, we're going to look at what happens when the exponent is 0. So anything to the 0 power is equal to 1. Now this works for fractions, decimals, positives, negatives, variables. So a to the 0, because that's taking something to the 0 power, that's going to equal 1, regardless of what a is. 3 to the 0 equals 1. Negative 8 to the 0 is 1. Now there's two things that we need to be careful of. Okay, first, if the negative, just like our last example, if the negative is not attached to the number, our order of operations tells us to do 8 to the 0 first, and we get 1. And then our final answer is negative 1. Now, 0 to the 0 is a special case, and we will talk about that in class together. Now with negative exponents, I want you to first think of an apartment. Now this apartment only has 2 stories, either the bottom floor or the top floor. And we want to make the exponents happy. Now to make exponents happy, we need those exponents to be positive. And we're going to move those depending on if the exponent is a negative exponent, that means that part of the expression is not happy, so we're going to move them to the other floor. And eventually we'll get everything to be positives. All right, so some laws of exponents. The first one we're going to look at is called the product rule. And when we take something with the same base, we've got to make sure that it's the same base, so it's a in both cases here. We're just going to add the exponents. The next one's very similar. It's called the quotient rule. And again, we need to make sure the bases are the same. And this time, we're going to subtract the exponents. The next one is called the power rule. And in this one, we're going to multiply the exponents. And then these last two examples sort of combine some of these rules above. So this first one is called the power of a product rule. And then the second one is called the power of a quotient rule. And both of them are very similar in terms of what we're going to, or how we're going to simplify this. We're going to distribute the exponent. Now you'll notice I sort of put that in quotation marks because we're not really distributing the exponent as you would with the normal distributive property. But if you'll notice, everyone inside the parentheses got raised to the m power, which in my opinion kind of reminds us of that distributive property. So it's a pretty easy way to remember it. We're going to work through 6 examples together, and I'll sort of explain my thinking through them. So our first example, if we're checking out what's going on, we've got a couple coefficients, we've got mainly positives and a couple different variables. So I'm going to first rewrite things just so that we see that really this is just one gigantic multiplication problem. Okay. And I'm just going to focus and find things that are the same. So first, with these bases here, the 3 and the 4 are whole numbers, are real numbers, so we're just going to multiply those together. Next, we're going to look at the x's. Now this, since they have the same base, we will go ahead and use the product rule. The product rule tells us we're going to add the exponents, so 3 plus 1 is 4. Now in this one, we don't see, if you focus especially on this second one, you don't actually see an exponent. If you don't see an exponent, we're just going to assume that that is raised to the first power. And then the last thing we need to focus on is the y's. Again, find those things with the same base. And we're going to add those exponents and get to the 9th power. And that right there is our final answer. Next example. The first thing that sort of jumps out to me is we've got this exponent here. So this is going to now be our power rule. So everything is going to get raised to the 4th power. So 2 just gets raised to the 4th power. A squared gets raised to the 4th power. Now this is where we said we're sort of going to distribute the exponent. So we're going to multiply those exponents because it's the power rule. Same thing happens with the b. We're going to multiply again. And then with the c, again, we don't see an exponent, so we assume it's 1. And then 1 times 4 just gives us 4. Now the variables are taken care of here, and we're done with that part. But the 2, I think that we can simplify that a little bit more. Now there's not a great rule of when you should and when you shouldn't simplify. It's just kind of a common sense feeling. A lot of times if we have a base of 2 or 3, something easy like that, and then especially smaller exponents, I would expect you to go ahead and simplify those. Obviously if we have something like 17 to the 25th power, we're not going to expect you to simplify that. Okay, now we just start adding more things to our expressions here. This first one, we have an exponent of 2. So everything in this first expression is going to get raised to the 2nd power. And then here we have a 3, so everything is going to get cubed. Everything's going to be raised to the 3rd power. Now if you'll notice, we have numerator and denominator on this fraction. I'm first going to deal with the real number, 2 squared. That's just going to give us 4. Now if you'll notice, we're going to focus on the r's first. I've got r to the 6th on the top and then r to the 9th on the bottom. Now we talked about using the quotient rule, and we said we're going to subtract. So 6 minus 9 gives us -3. But then another way to think of it is up on the top you had 6 r's, while on the bottom we had 9. Now if we divide, each of these is going to get paired up with 1 on the top, 1 on the bottom. And if you'll notice, there's R3, and so that's how we know that the r's should end up in the denominator. For the s's, again, we'll use the quotient rule. 3 minus 2 is positive 1, so we know it's going to stay on the top. You could write s to the first, but really we want to just get in the habit of leaving it as s. And so that's our final answer for that one. Last example here, for example 1, just uses the power of a product rule thrown in with some negative exponents. So the u is happy. It's got a positive exponent, so it's going to stay on the top. Now remember, this right now, even though we don't see it, it's technically, as a fraction, it would be over 1. So again, the u to the 6th is happy on the top floor of our apartment, so it can stay there. However, the v is not happy, so it needs to move to the bottom. Once it moves to the bottom, then it is happy. So then the exponent should become positive. Example 2 here deals a lot more with negative exponents. So this one, there's a couple different ways that we could do this. I'm actually going to move all the exponents to where they need to be first, and then I'll go through and simplify things. So the x to the third is a positive 3, it's happy where it's at. The y to the negative 5th is not, so it needs to move to the bottom. The real numbers don't really move around. X to the negative 1st is on the bottom, which is not happy, so it goes to the top and does become happy. The y squared is on the bottom, and it's happy where it's at. So now we're ready to simplify. With our real numbers, 8 divided by 4, that just gives us 2. The x's, we're going to use our product rule, which tells us we will add our exponents. And then the same thing happens on the bottom with the y's. We're going to add those exponents. 5 plus 2 gives us 7. And there's our final answer for that one. Final example for this section, we've got a negative exponent, and we're just going to raise everything here to the negative 3rd power. Now we're going to move stuff around because of that negative exponent. So the u to the negative 3rd needs to go to the bottom. The 2 to the negative 3rd, that needs to go to the top. And let's go ahead and just multiply that out. 2 to the 3rd, we can move that to be 8. And then v also needs to come to the top. And once it moves to the top, now it is a positive exponent. And that's the end of part 1 for this section 1.2, exponents and radicals.